Hello everyone, this is Srikanth, working as STM professor in electrical department. Now we are moving to one more very important topic, that is two-port networks interconnections. So when two-port networks connected in series or parallel or series and parallel or any manner, okay, when they are connected each other, then what is the process to add those values? Two-port networks connected each other here. So consider any two-port networks. Before going to two-port networks, here I have two resistors connected series. Series means here the positive and negative, again positive and negative. Okay, and two are connected in parallel. So two are connected in parallel. Parallel means just observe. So positive and negative. So both are connected in parallel. And same thing series and parallel, that is both series and parallel connections. And if you observe here, two-port networks, they can connect series and parallel, and one more we have cascade. So cascade connection also we have. What is a cascade? We'll check it now. Okay, here one more also is we have, that is series and parallel. Okay, if you know series connection, if you know parallel connections, no need about this. Okay, series, parallel and cascade. We will discuss three different connections. Why we want to go for this series parallel values? So in your transmission line or in your big circuits, when you have the big circuits, when you have the complex circuits, we need to calculate those complex circuits, means very difficult. So for that purpose, we are moving to here series parallel connections and one more cascade also. Okay, we'll check it one by one. So first one, like series connection. Yeah, I have two-port networks. I said like when two resistors are in series, so positive, negative and positive, negative. Okay, here I have two-port networks connected in series. So series means we need to connect negative and positive each other at point. So when we have the series connection, the current is same. Voltage is different. Here V1 and here V2. Different values. But current is same when both are connected in series. Same manner, here I have two-port networks. Two-port networks. One is P and one is S. I have two networks here. So both are connected now in series. I need to connect both in series. So what is the process? So if suppose positive and here negative and positive and negative. That is primary side. When two-port networks means four terminals we have. This is two-port network. I have four terminals and this is the primary. So input side and output side. So primary and secondary. We have four terminals. So here positive, negative, same thing, positive, negative. So primary side positive, negative we have. Secondary side also we have positive, negative. So same manner here I have two-port networks and it connect both are in series. So series means so here which manner we have negative, positive, same thing, negative and positive. So I have four terminals in that, two negative and positive connected each point. So at point. So same thing secondary side, negative and positive. Okay, same. Here current is same. So here we have like I, but I1 of P, and here I1 of S. Okay, in that we have I2. In simple manner, for P network we have I2 of P, and same thing for S network also, I2 of S. And voltages, here V1, here V2, but between like P network we have different voltages. So V1 of P and V1 of S. So V1 of V2 of P and V2 of S. Okay. So here two-pole network connected each other. So then positive and negative. So here positive and this negative both are is connected. I1 current and I1 of P current both are same. It's one line. Okay. Now we'll check it the connections which we have now. Uh, so both two-pole networks we have. So we have like positive values and negative values for negative values. So total two-pole network I want equivalent value. For that we have V1 and V2 values, and where we have like a negatives and positive both are connected now each other. That means the two-pole networks connected in series. Now we have I1 of P. So this is primary like a which network P network. So P network values and S network values, primary side as well as secondary side. Now we have V1 and V2 and the currents. Here we have I1 and here we have I2. Okay. Now if you here the current are same. When you have the series connection, the current are same and the voltage are different. So which method I need to use? So when two-pole networks connected in series, then we need to follow the Z parameters. So which we have like impedance parameters, Z parameters. So Z parameters means Z the value, which values we have. So V1 and V2 in form of I1 and I2. So we can find out the different voltage which we have. Okay, we can find out the different voltage which we have and the currents are same. Okay, so when the different voltages and current are same, that means both are in series. When both are in series, we need to follow the Z parameters values. Okay, so what is the Z parameters equations? So V1 equal to Z11 I1 plus Z12 I2 and V2 equal to Z21 I1 plus Z22 I2. We have two equations. So from two equations, so V1 and V2. So for P networks, we have V1 and V2, and same as for S network, we have V1 and V2. Just write those values, which values we have for P networks impedance values and S networks impedance values. So for P network, right here, so P network impedance values. So Z1 of Z, you can say like a P values. So V1 of P equal to Z11 of P plus, so into I1, okay, I1 of P plus Z12 of P into I2 of P. Same thing, V2 of P equal to Z21 of P plus, so not plus here, I1 of P plus Z22 of P, I2 of P. So which value we have in Z networks? So Z impedance values V1 and V2 in form of I1 and I2. But here we are primary like a P networks values. So P networks values we are writing here. So I mentioned with P. That's it. Okay. Same thing for S network. V1 of S equal to Z11 of S, I1 of S plus Z12 of S, I2 of S, and V2 of S equal to Z21 of S, I1 of S plus Z22 of S, I2 of S. So these are my P network and S network's values. That is impedance equation, Z parameters equations. Now I want to add both values. So when both are in series, we need to go for equivalent value. So here two-port networks connected in series. So I need to go for the equivalent values. So equivalent value means in general when two resistors in series, then R1 plus R2. That is a general manner. But here we have two-port networks. So two-port networks I need to add impedance values. So same which we have for resistor, same thing when two are in series, two-port networks are in series, then go for the addition. Okay, if suppose I want this V1 value in form of I1 and I2. Okay, V1 value in form of I1 and I2. Then your value, so V1 equal to, so here you need to use the currents, which currents we have. So currents are same. So we need to add both values. So here Z11 of P plus Z11 of S into I. So why I1? Here which value we have? I1 value and I1 of P value, both are same. Am I right? So I1 value and I1 of P value, both are same. So we are writing like Z11 of P plus Z11 of S into your I1 and plus Z12 of P plus Z12 of S into your I2. Clear, guys? So the currents are same for two-port networks. So when both are in series, then both parameters like which value we have, P network and S networks, impedance values, so Z11 and Z12 values. So Z11 of P and Z11 of S, both are in addition place. Okay, same thing, V2 value, we will check it now. So here we have P network values, and here we have S networks values. Then V1 value in form of I1 and I2, in form of V1 and I1 and I2, the values are, so Z11 of P and Z11 of S. So these values, so add those values, which value we have, and same thing 1, 2 values. So I1 and I2. So I1 is equal to I1 of P and I2 is equal to I2 of P. Clear? So this is about like a two-port networks, series connections, and in exam or anywhere I will go for the sum problem. So it's very simple. It's very, very, very simple. So we have like any circuit, given like any circuit, two circuit connected in series. Okay. So any circuit. So I given like circuit like T network or pi network circuits. So both are connected in series. So both are connected in series. Then you need to find out the impedance values. So when both are connected in series, we need to find out the impedance value for each circuits. Then add those values under the equations. Very simple. Okay. So from this circuit, suppose in any one example circuit, I have like Z11 is 2, Z12 is 3, Z21 is 4, and Z22 is 5. So some example. From this circuit, I have like Z11 equal to 1, Z12 equal to 2, Z21 equal to 3, Z22 equal to 4. So on different values here. So I want to find out the equivalent value. So I'm going to go for the one single two port networks. So one single two port networks values. For this circuits, the V1 equal to provide the values Z11 plus Z11 of one more network. So 2 plus 1, 3 I1 plus 3 plus 2, 5, 8. So V2 equal to same 7 I1 plus 9 I2. Okay, it's very simple, but you need to know when two port networks connected in series, then which parameter you need to use. That is Z parameters. So Z parameters, the values, which values for two networks, which values for two networks. So Z11 and Z11 of another networks. We need to add both values. Okay, so this is about two port network connected in series. Now we are moving to two port networks connected in parallel. So same manner. So I have two port networks. Now both are connected in parallel. Parallel means here I have two resistors connected in parallel. Parallel means positive and negative. And here one node and here one node. So same thing, positive, negative. Same positive, negative. Then here positive connected. So positive connected, I have one line, and negative connected, I have one more line. And in parallel we have the voltage is same. In parallel voltage is same, current is different. So here I1 current and here I2 current. So voltage is same. So same here. So positive, I have one line, and negative. I have one more line. Okay, and so here which currents we have? So I1 of P, and here I1 of S, I2 of P, and I2 of S. And here we have the I1 current, and here we have the I2 current. Here we have like a I1. So no, here I1 current, here I2 current. Okay, and the voltages. So primary voltage V1 and secondary voltage V2. And which voltage we have? So here to here we have V1 of P, and here to here we have V2 of P. V1 of S. And same thing here, V2 of P, and here V2 of S. So P network, S networks, the values. Okay, so when two port networks connected in parallel, then which impedance or which parameters I need to follow? Which parameters? So Z parameters, Y parameters, or ABCD parameters, or any other parameters, H parameters. So when two port networks connected in parallel, so two port networks connected in parallel, then the voltage is same, but current is different. So which parameters we have? That is admittance parameters. So Y parameters. So if you check it here, one second, here we have two port network connected in parallel. Just observe positive and negative, and positive and negative. See this? It's like looking very nice. Okay. Now the values. Which values we have? So P network's values and S network's values, and we need to find out like a I1 as well as I2. So I1 and I2 we need to find out. Why means the voltages are same here. The voltages are same when both are connected parallel. The voltages are same. Okay. Now, so which method I need to follow? Y parameters. So I need to use Y parameters and get the I1 and I2 values. Y means Y parameters. So we have the Y parameters in form of Y parameters I1 and I2 in form of V1 and V2. So voltage are same here. So current are different. So your admittance parameters I1 and I2 in form of V1 and V2. So your equation for Y parameters. So here I1 and I2 is equal to Y11 V1 plus Y12 V2. Same Y21 V1 plus Y22 V2. So we have I1 and I2 in form of V1 and V2. Okay, then write the values for each like a P network and S networks. So here we have P networks, the values are so in I1 of P as well as I2 of P. I1 of P and I2 of P. So here we have Y11 of P into your V1 of P plus Y12 of P and V2 of P. And same thing Y21 of P and V1 of P plus Y22 of P and V2 of P. And we have like a S network's values I1 of S, not P. S is equal to Y11 of S and V1 of S plus Y12 of S and V2 of S. Same Y2 of S is equal to Y21 of S, V1 of S plus Y22 of S and V2 of S. So two values, two two-port networks values in form of Y parameters. Now, I need to add or subtract those values. So when two two-port networks connected in series or parallel. So when they are connected in series and parallel, no need to worry about that. So we need to add those values, that's it. So there we are adding the current values, here we are adding the voltage values. So both are same. So when both are in same, so their current are same. Current are same means we need to remove the V1 and so there we are removing the current values and adding those impedance parameters. Now here we are removing the voltage values and voltage values. Why means here voltage are same. And we need to add those values here. Okay. Now, then write the value for I1 and I2. Equivalent value when two two-port networks in parallel. Then Y11 of P plus Y12, so 11 of S into your V1 of value as well as Y12 of P and Y12 of S into your V2 value. So same thing for secondary current Y21 of P plus Y21 of S into your V1 value as well as Y22 of P plus Y22 of S into your V2 value. So when two two-port networks connected in parallel, then we need to go for the Y parameters. So Y parameters values, which values we have. So P networks as well as S networks values. We need to add those values. Okay, we'll check it now. So here we have P networks values and S networks values. These are the P networks values and these are the S networks values. So P and S both are in Y functions. So admittance parameters values. Now your equivalent value is we need to add both values. Okay, so same thing when I have two networks connected in series or parallel. So we need to find out the equivalent value. So we need to find out the equivalence value when we have like series. Then we need to go for the impedance parameters and now here both are in parallel. So this network and this network connected in both are in parallel. So parallel means we need to go for the y parameters. So admittance parameters. Then find out those values, y11 of this network and y12 of this network, y21 and y22 of this network. Same thing, secondary network also. We need to find out those values, and we need to find out the equivalent value means we need to add both. We need to add both values and write the I1 and I2 equation. And guys, when two networks are parallel, then we need to go for the admittance parameters, means we need to find out the admittance values using any method. So we have a number of methods we have. So primary is open, or secondary side open, otherwise you know like z values, you can get directly find out the y values. Okay, which method are easy for you, just use those values, those methods, and find out those admittance values. Okay, and this is about like a two-port networks connected in parallel. Then we have one more method, that is two-port networks connected in cascade. So what is the cascade? So cascade network, nothing but, so two networks, so S and P. So both networks connected in one line. So this is a P network, this is a S network connected in only one line. So same line. So here I have one network and here we have one more network. So both are connected in one line. Then the connection is nothing but cascade connection. Okay. So we'll check in the circuit here. So P network and S network, that four terminals are connected each other. Now if you observe the values, so here which voltage we have? Same voltage, and the currents also same but reverse direction. So B network secondary side current and S network primary side current, both are reverse direction. So when the reverse direction means which parameter we need to use? So that is, so when we have the primary and secondary, so we have using the primary values in form of secondary. Same thing, the current direction also reverse. Then we need to go for the transmission line parameters, that is ABCD parameters. So here we need to use ABCD parameters. So ABCD parameters means V1 and I1 in form of V2 and I2. So two-port networks connected in each like one line, that means cascade connection. Then we need to go for the transmission line parameters. The parameters is primary values, that means V1 and I1 in form of secondary values, V2 and I2. The current direction is reverse. So your equation for transmission line parameters, you can use like T11 and T12 and T21 or T22, or you can use like ABC. Okay, anything you can use. So generally ABCD parameters, the values V1 and I1 is equal to A V2 minus B I2 and C V2 minus D. So here minus means the current direction is reverse. Now this is for general transmission line parameters. So I need to use P values as well as S values. So P network ABCD values. So P network's ABCD values means V1 of P and I1 of P is equal to A means A of P. A of P V2 minus B of P I2. Same thing, C of P V2 minus D P. So these are the like P network. Same as for S network also. V1 of S and I1 of S. So A, B, C, D of S. and same thing we have V2 minus I2, V2 minus I2. So it's very simple to write those equations when you know the functions and equations values. So here we have two-port networks values. Now, when we have the series, then we need to add those values, impedance values, and both in parallel, then we need to add both admittance values. Then here, both are in cascade connection. Then we need to add or subtract or multiply. So series means their current is same. So current value same means we need to add those values. Parallel means now there also we have the voltage same, so we need to add voltage values. Now here, no same. So only secondary side is same. So here secondary, but this is a primary. So for this transmission and parameters, we need to multiply those values. So here A, B, C, D and A, B. So A, B, C, D, A, B, C, D. Okay, we have values. Now the values of each two-port networks. Each two-port networks need to multiply. So here V1 and I1, V1 and I1 is equal to A of P and A of S into V2 minus A, so B of P and B of S into I2. Okay, same C of P and B of C of S into V2 minus D of P and D of S into. So we need to multiply both values, which parameters values we have. That means transmission and parameters values, we need to multiply both values. Okay, we'll check it now. Here we have P network and S network connected in cascade. So those values, P network's values and S network's values. Now your equivalent value when two-port networks connected in cascade connection, then the equivalent value is we need to multiply those A, B, C, D values. So transmission and parameters values. Okay, so when two networks connected in cascade connection, then we need to multiply those values. We need to multiply those values. So here we have any type of networks. So I'm writing here T type of network. So T type of network connected in cascade. So then we need to go for the A, B, C, D values for both networks and we need to multiply both values. The equivalent values, we need to multiply both values and find out the primary values V1 and I1 values in form of V2 and I2. Okay, so this is about like a series, parallel and cascade. I want to go for small problem here. So here we have two-port networks. Consider any one. Here I have like a T network. So same thing here I have one more T network. So in general, I want to find out the equivalent values when series, parallel as well as cascade. Now I want to go for the first series. Remaining we'll discuss in the next video. So here both are in series. Now we'll check it the equivalent value. Consider any value 2, 3 and 4 and here also 2, 3 and 4. So same network, if you know the one network value, you can find out the same network value. Okay, for simplify purpose I am writing the same values. So here we have like a I1 and V1, I2 and V2. Okay, it's one network. So one network's values. Now for this network and find out the impedance values. Why impedance means both are connected. So both are connected each other in series. Now your impedance values. Impedance value means V1 and V2 in form of I1 and I2. So Z11 plus Z12, Z21 plus Z22. Now I want like Z11 value. So Z11 value I required means I2 is 0. So when I2 is 0, so for this network I2 is 0. So suppose the I2 value is 0, in both condition I2 value is 0, I can find out like Z11 value and Z2 value. So Z11 and Z21 values. When I2 is 0. I2 is 0 means secondary side is open. Secondary side is open. So for this network, I have the 2 ohm resistor, 4 ohm resistor and 3 ohm resistor. Secondary side is open. Secondary side is open. So I have only V1 value. V1 is suppose like a 10 and 20. Some different values. So remaining 2 and 4 and here 3. So secondary side I2 is 0. So secondary side is open. So we have the I1 value. And we need to find out like a I1 value and V1 we know like 10 volts. Okay. From this equation, first equation, if I want Z11 is nothing but V1 by I1. And from this equation, Z21 is equal to I1 by V2. Sorry, V2 by I1. V2 by I1. Okay. So I need like a V1 value and V1 value, I1 value, V2 value, I1 value. So V1 value, I know like V1 equal to 10 volts. So I know the V1 value. Okay, I require I1 value. So here from this circuit, so 3 ohms is in open place. So no need to require like 3 ohms. Now 2 and 4 both are in series. So it's a one loop. So one loop means we have like I value. I value is I1 value here. I1 equal to 10 by 2 plus 4, 6. And I require one more value, V2 value. So which voltage, here voltage value I required. In a exam he given like V2 is 20. So for this circuit, I2 is 0. So no need to use the 20 value. That is wrong. So you need to use the V2 value in this circuit across 4 volts. So at 4 ohms, which voltage we have, that voltage is nothing but your V2 voltage. In exam, he given like in circuit, he given like 20 volt. 20 volts he given, but here your 20 volts is wrong. Why means I2 is open. When I2 is open, so you need to use your V2 value is 4 ohms across the voltage at 4 ohms. So I require the 4 ohms voltage means V2 value is 10 by 6 into 4. That is your V2 value. So I, that is I is same, 2 ohms and 4 ohms I is same, I into your R. So we have 20 by 3 is your V2 value. Okay. So this is about like V1, V2. So V1, I1 and V2. So V1, I1 and V2 values. Now you can find out those Z11 value and Z21 values using this value. Now one more condition. Now I1 is 0. So here I1 is 0. So when I1 is 0, I can find out Z12 value and Z22 value. Even Z12 value is again V1 by I2 and Z22 value is V2 by I2. Now I need V1 value, V2 value and I2 value also. Now your circuit. So this circuit. So primary side I1 is 0. I1 is 0 means primary side is open. So I1 is 0. Primary side is open and secondary side is need to connect. Okay. Here 3 ohms and 4 ohms I have, and the values voltage I need to use, that is 20 volts. V1 is we need to find out the V1 value. So Y means primary side is open. So primary I1 is 0. So primary side is open. So I need to find out like V1 value. I have 20. I need to find out I1 value. So I2 value as well as V1 value. V1 means again 4 ohms across. Okay. So I know the value of V2 is 20 volts. So your I1. So I2 value is I1 is 0. So I2 value is 20 by 7. So 20 only on loop, that is I2 current. So here 2 ohms is no need to consider. It's a open. So 3 and 4 both are in series. Series means 3 plus 4 is 7 and 20. So V by R nothing but your I value. So 20 by 7, that is your I2 value. Now coming to V1 value. So across the 4 ohms again across the 4 ohms, but V2 is acting. So your V1 value is 20 by 7 into your 4. So like this, we need to find out the Z11 value, Z21 value, and Z22 value, and Z12 value. So we need to find out each value. Okay. Then, so same circuit means we have the same values. So add both values when both are in series. So this network and this network both are in series. The values Z11 and Z11. So first network and second network into your I1. Same thing Z12, Z12, 1 dash and 1 network into your I2 value. That is your V1. Okay. And same V2 equal to Z21, Z21. So here plus we have, not multiplication position, plus position. And I1 plus Z22 plus Z22 I2. Okay. That is equivalent value for 2 networks connected in series. Connected in series means you need to use the Z parameters. So Z parameters means you need to use any method. So here I have like a two networks connected in series. I know the equations. I know the equation for both network, and you need to use when the I2 is 0 means primary side, the secondary side is open, and find out the I1 value, V1 value, and V2 value. Here V2 value means across the 4 ohms. And same thing, primary side is open, so I1 is 0. So I1 is 0 means I know the V2 value, and it find out the I2 and V1 value. Across the 4 ohms again V1 value. Okay, so this is about two port networks connected in series, parallel, and cascade. So any queries, comment in comment box. Thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.